Hey, what's going on, guys? Geeky here. Welcome to this experimental JavaScript chessboard tinkering crash course. So I've created an experimental JavaScript library, which I said a few words about this in a previous video, in a previous part, in the very initial one, when I didn't really know exactly what am I doing and for what purpose. But I'll give you a link in the description below the video. Also, the picture that you can now see on your screen, it's my local file, but this is also available in the live mode, so you will be able to play around with this example on your own site in your browser. Apart from the Bootstrap user interface, we have a pure JavaScript implementation of the chessboard that knows rules of chess. And that's despite the fact that eventually I wanted to create an embeddable chessboard widget that one could have used in his own production website or something. Later on, I've changed the goal of the project because of realizing the fact that every single kind of like production has its own needs, and I can't really cover all the possibilities. And actually, I realized that I don't really even want to try doing that. Instead, at this moment in particular, I understand that this sort of a project accumulates my both chess engine development techniques, code bases, things like that, and also the GUI related stuff. So basically, it's kind of some sort of a summary for everything I've been doing before as a chess programmer. And what I really would what I really want to be happy with regarding this project, if I would be able to explain you how it works and what in particular you can do with this, and how you can make use of it, and hopefully trying to build something interesting on top of this code base. So I can't even call this a library in terms of like the real world libraries operate. It's more like for tinkering, really. But anyway, let me just demonstrate the eventual functionality that I came up with, and actually the stage where I'm not going to be developing it further on, due to the fact of reaching this stage, the state of satisfaction with this sort of a project. And then we'll go through the source code in great detail, so you would be able to manipulate the source code to make it fit in your own purposes. So if you're interested, without further ado, let's actually start. So I just update the page to make sure all the variables are updated correctly. So we can either make 2 clicks moves, which is really a good idea for touch devices. And by the way, drag and drop should be disabled on touch devices automatically. But also on the desktop, we can use this sort of a drag and drop like this by simply dragging and dropping pieces, so it's quite pretty easy. And also this board keeps track of so-called move stack, so we can go to the very first move, we can get back to the last move, and we can navigate through the moves one by one. Well, obviously it's not safe in terms of if, let's say, somewhere in between you'll make whatever move, it would be pushed onto the stack, and then if you consider it in terms of PGN, the kind of PGN-like stuff would be malformed. You can just try it on your own to understand what I mean. But anyway, this is just the proof of concept implementation to give an idea of how the move stack could work. Well, obviously, if it comes about the real PGN, probably some nested lines should be implemented, but assuming the current implementation, it's going to be quite pretty trivial to add. So I'm leaving this for you guys to play around with. So let me just update the board. So when we update stuff, move stack is getting cleared. So now let's, I just want to input the moves in. So I was thinking about inputting the PGN here, but again, like from the chessboard perspective, it's the matter of a move sequence to push onto the move stack, right? And I was trying to make it most compatible with so-called UCI protocol, which interacts via the list of moves in this like notation. So E2, E4, E7, E5, G1, F3, b8, c6, and so on. So if I just set this position, it pushes all the moves onto the stack, so we can loop over these moves in this like sort of a manner. So I hope this is clear as well. Also, we can set the FEN. So if it just, well, I'm already coming to the source code, so probably it's also a good idea to demonstrate. But well, first let me just go to this Chessboard Js kind of part, and I just want to grab some sort of a FEN string here. So we just grab the FEN string and paste it here, click set. I'm getting the FENs, the board position and board state variables like side to move and peasant square if available, canceling rights been set up correctly. So no moves at the moment, but if we just start making moves at this point, it's somehow, in this case, we can again like manipulate these moves quite pretty nicely. So that's kind of the functionality that is at least available in this sort of a sort of an example. So I hope that's clear as well. Just want to quickly check out the fact of, yeah. So the first move, make sure the first move is there. Okay, so now let's actually go to the source code and see how in particular we can make use of this, sort of a library. Well, a bit of my bad is actually the fact that I'm initializing the board constructor within the JS file instead of doing this in the HTML, which is a little bit wrong. So here is the UI, nothing special. I'm using Bootstrap to prettify the layout itself and to provide this fancy buttons, but the chessboard itself is written in pure JavaScript. So in order to import the chessboard, we need to import this script with the source to chessboard.js. So this is the script file. So this is the entire library. It lives within this JS file right over in here. So we'll walk through that file quite pretty soon. And also regarding the view element, we need to make sure that we create a div that has an ID of a chessboard. So this is the div. So literally these two lines of code are already enough to see a chessboard on your in your browser page. So you need to create a div. This is the bare minimum stuff, creating a div with the ID of a chessboard, and nothing else but exactly the chessboard. It's important. And here we need to import this chessboard.js to make it kind of work. So, well, obviously, yeah, this is kind of like, yeah, this is, it's wrong to have a test driver within, here. So let me just, it shouldn't, yeah, now it doesn't bring the board. So I just want to, let me just grab this code from here, from the library part, and go into example. And here, I create another script like this. And here, I'll just show you how to instantiate the chessboard. So we'll start with a very simple example. So, okay, yeah. So we creating the board, the variable board, and just creating a new board object here. So one of the very important things to consider, this variable should be named board, because otherwise it's not going to be working, because this board is involved within the drag and drop and on click functionality in the library itself. So I know probably that's not really the best ever idea of doing things, but I don't know how to make it better, so that's kind of, so make sure to call this variable board, otherwise it's not going to be working. Just probably it would be better to demonstrate. So just re-enable this stuff. So by providing this single line of code, we can already have this sort of behavior I've been showing you guys. But again, like, just to give you an idea, if we create this, call it not board, but somewhat a different stuff, we can't move pieces or do anything because the on-click events and on drag-and-drop events are not going to be working because they rely on the variable that is called board, not something else. So to make sure it works, you just need to make sure that you call in the instance exactly board, not something else. Sorry for this weird limitation, but that's kind of how it works. So I hope this is clear. Now the next thing to consider, if you want to change the board appearance, it's very simple. So there are up to 4 parameters to change the board appearance. So this is the board width, assuming the board is always going to be the square shaped. No need to provide width and height, only the width. And dark squares, light squares, and select color. Well, maybe light squares and then dark squares. To be honest, I don't really remember that. So let's have a look. It should be the same board, but okay, it's probably because let me just update this way. Now it should get updated. Okay, it's probably pre-caching stuff here. Okay, where's my network tab? Hold on a sec. Oh, I just didn't save it. Okay, just didn't save it. So yeah, one update. Now we have different colors for light squares, dark squares, and also different colors for our highlight square. But the functionality is all kind of the same. So yeah, kind of like hope that's clear as well. If it comes to the checkmate or to the stalemate, by default it would just it won't allow you to move the pieces because those moves would be considered to be illegal. So I hope that's clear. The next thing to consider, well, I personally really like this appearance, and I actually made this sort of appearance to be default one. So it's really kind of like more colorful and fancy. I don't know, I really like it more compared to what we had. So yeah, I think this might just kind of make some sort of a sense here. And so just yeah, okay, okay, so let's move further on. I didn't yet dive into the source code itself, so this is just a matter of creating the instance. Again, like exactly something that regards tinkering. So there is a method called tests, and if you just open the developer tools, go into console and update the page, what it does by default it just sets a specific board position. Also this is done in the UI as well. So print board function gives you all the information regarding the internal variables like side of move, castling, rice, and peasant square if available, 50 rule moves counter, position hash key, which is unfortunately 32-bit signed number, which is not really that great idea for hash keys, but still it kind of works. And here we have a move list specifying the move types, move flags. So if this is the capture move, if this is the double pawn push and peasant capture or castling, well, something goes horribly wrong with the castling flag. I probably just needed to make it a bit to open a bit wider here. And then also it has a built-in so-called Perf Test, which is a proper way of making sure that the mode generator is bug-free. So mode generator is a big function that it's not even a function, it's kind of the entire module that ensures that the number of nodes that we're traversing recursively within the move tree being generated is correct. So these numbers, depending on depth, are well known. You can check them out. Check them out, say on Chess Programming Wikipedia, on Perf Test results pages. Anyway, so this means that the mode generator is correct, and this means that you won't ever be able to make an illegal move on a chessboard. So I hope that's quite pretty clear as well. And now another interesting thing regarding these tasks here. So we just go now we're coming to the actual JS part of the library. So it has kind of two kind of functions. Let's say we have publicly available functions. Well, these four functions are not intended to be changed because they're used by the GUI. So this is just a matter of handling either double click, or I call it tap piece if it's from the touch devices perspective, or drag and drop. So this kind of stuff is handled automatically, but it needs a global scope just to interact with the browser's DOM elements. I hope that's clear. And this is called API reference. So here we have hooks for the functions that are available in public. So we can set FEN, undo move, redo move, go to first move, go to last move, read moves, and run these tests. So that's the bare minimum we have here. So undo, redo, first, last are the functions that are called when we clicking on this button. So just give you an idea what's happening. So just inspect the element and okay, this button. So on click we have this go into the first move within the move stack. Here we go to the last move. Here it is. So here we go to the last move. This button we just redo the move. This button we undo the move. So it's just a matter of navigating within the move stack. Just to give you an idea how the move stack looks like, is the simple object. So we just go to the move stack. It's globally available within the board object. So the entire board object is a single function, and all the variables are relying within the scope of this sort of a function. So we among other variables we have this move stack. So it supports up to 1000 moves here. Count serves as a pointer to the current move. So this count is being shifted like incremented or decremented when it comes to navigating through the move stack. And then we're referencing the moves array by a given count. And size is needed to give an idea of the overall number of moves available within this move stack to avoid overlapping just to avoid incrementing this pointer. It's not a pointer, this index greater than the size of array. So just a pure technical reason for actually specifying this size here. Again, like if you want some nested forcing lines, or not, maybe not forcing, if you want some nested lines in your moves, probably some sort of a nested stack should be implemented here. Like the stack, the move stack would be would have an opportunity to recursively encapsulate this the same kind of object. I'm not sure. It's all on you and how you would like to implement this, if you ever want to implement this. So okay, as far as we are within the source code, let me just quickly walk through the source code. Even though I did this before in the previous video, still I just want to make it one more time to give an idea how it works. So it has a pseudo-random number generator, which generate the same pseudo-random numbers regardless of operating system, browser, and whatever external circumstances. So this random function can generate a 32-bit random number using so-called XOR shift algorithm. And again, like whatever function we have here within the scope of our board function here, of this function, can be referenced from the tests. So if you just scroll down a little bit, and so here you see like we have these tests. Okay, so in order to run this test, as I've already been showing, we can simply say like board.tests and we're done basically. Well, obviously we can do the same with the FEN, so that's something that is happening when well, let's say this button. So just inspect the button here. So on click we're doing board.setFEN. So we could do this just here within the script, but here I'm making this on click event. And this set button goes for read moves, which loops over the moves being presented here, and then it just populates the move stack, so eventually user is able to navigate through the line through the line basically, regardless of whether it comes to the very end of the game, to the mating position, or just a sequence of moves. So I hope that's clear as well. Yeah, so that's kind of it. And now the tests. So if you want to reference either the internal variables of the board function, or make use of the functions being available there, you can try to call them within this tests here. So here's the test section here. So here I was trying to set if en print board, creating a custom move list. Oh, by the way, anyway, every time you want to create, you want to generate moves, first you need to create a move list, and then you're passing this move list. Well, it's a pointer literally. So you're passing a pointer to the move list, to the generate moves functions, and that's how. This makes the generate move function to actually store the generated moves into this sort of a move list that you've created just right before it. Also, if you want to print the move list, again, you need to reference the particular move list to use as a source for the moves you're trying to print. So I hope that's clear. Perf doesn't take any pointers, only the depth at which you want to run the perf. But bear in mind that in JavaScript is very slow, and this move generator is not the fastest in the world one. It's quite pretty slow as well. So if you say make it like perf 5 or 6, it would really take ages to complete. So just be aware of that. Okay, and again, if you want to reference whatever variable that is available, if you say you want to check the board variable that is available here in the source code, say this is board variable, or a side move, or in peasant square, castling, or move stack, or whatever variable. In that case, you can do it in a very simple way. So let's go to this tests, and I just want to let me just get rid of the perf test for a while, and I can simply say console.log, and let's just want to print the board here. So if I just update and go back to the console, here we got the board array being printed in its kind of raw representation. So pieces are encoded as integers. So it doesn't really tell you much. So that's the reason why I've created this print board function that brings the board position in a more human readable way. But again, you can print the side castling in peasant, everything. So say side would be either 1 or 0. So 0 for white, 1 for black. So here if you just say print the side, you can just see that it should be equal to 0, yeah, because it's white to move here. So I hope that's clear. Again, you can print the move stack. It should be empty now because literally no moves were done on the chessboard. Okay, stack just in there. It should be spelled like this. Nothing really here because we didn't really specify. We didn't really do anything. Didn't make any moves here. So I hope that's quite pretty clear. And literally whatever variable could be inspected within this test, and also whatever function can be called within the test. So from this test, you can reference the internal variables and functions of the board function, scope, or the board function namespace, basically. Okay, so I think, yeah, so really lots of them. So yeah, let's now quickly walk through the constants, variables, and the functions to give an idea of what is available here. And yeah, and then I'll show you one last trick on how you can extend the library itself and providing new API references to interact with the specific internal board variables or functions. And I think that would be it. So we start with the definitions. So sides to move are encoded as 0 and 1. So if you want to, so white, it's a constant that represents 0. Black represents 1. It's very useful because when we want to shift the side from 0 to 1, from 1 to 0, without knowing what kind of side we have now, we can simply use the XOR operator. So if we say like side XOR equals 1, if side was 1, it would become 0. If it was 0, it would become 1. So that's very fancy and simple way to change, to swap the side basically. Then it goes to the piece encoding. So white pawn, knight, bishop, rook, queen. So all these are encoded. So I hope the commentaries will give you an idea regarding this marks basically. So pawn, knight, bishop, rook, queen, king, and uppercase are white pieces, lowercase are black pieces. Well, these constants are pretty useless because, well, we're actually using this E, but we could have used 0 instead, so it's nothing much. This O is not used at all. It represents the off-board squares, so you can literally ignore this too. Not really that much need for those. Here we're encoding the squares. So if you want to know regarding the NDNs, so this is how it goes. So A8 is 0, H1 is 119. The board representation is known as hexadecimal 88. So we have literally two 64 square parts. So it's kind of left part. So from A to H, and then this right part, which is off board. So it shouldn't ever be used here. So this is just a placeholders to debug that I was using for debugging purposes. But literally all you need is this sort of this kind of part. So the next one of the useful things here, so coordinates. You can reference coordinates array by the square number, by the board square index. Well, say you have a board square index of 100 and you don't know what kind of square it regards to. So if you say, if here you say like coordinates and 100, it would give you E2 in return, because 100 is the exact index for E2. So I hope that's clear as well. So this is how you can use coordinates. You can convert board square indices into human readable coordinates. Unicode pieces is used internally by the printboard function to give you this nice, pretty looking chess piece representation when it comes to pretty print in the internal board position to the console. And again, like the indices of the pieces corresponds to the piece code. So we have this white pawn is 1, and the index of 1, we have the Unicode for white pawns. Hope this clear as well. Then we have some mappings between ASCII piece codes and the piece encodings. This is used when it comes to parsing the FEN. So within an FEN string, we have this ASCII representation of the chess pieces, but when we want to set them on a chessboard, we need to convert them to the specific encodings that are represented here. And this object allows you to map a particular piece code to the ASCII equivalent of a chess piece. So I hope that's clear as well. Something similar but not exactly the same regards to the promoted pieces here. So these square brackets allowing to use numeric values as keys within the JavaScript object. So queen, this would be, so if we just reference promoted pieces by the number of 5, we will get this little ASCII queue in return. And this promoted pieces is needed to provide the promoted pieces to append the promoted piece to the UCI like format move. So UCI is a universal chess interface. So say b7, b8, queening, or b7, b8 converts to rook, to knight, bishop, whatever. So for white and black pieces, we have exactly the same lowercase values because within the UCI protocol, that's the standard. Now, castling bits is a little bit, might be a bit complicated topic to to consider. But if you check my hexadecimal 88 move generator series here on Chess Programming channel, there is an extended explanation of how the castling bits work. So by simple bitwise OR and bitwise AND operation, we can manipulate the castling rights, the state of castling rights for either white or black, for kingside or queenside castling, by simply either bitwise ANDing with this constants or bitwise ORing with this constants. Castling rights array is used to keep track of the fact that either the rook or queen, either the rook or king has moved. In that case, we can't castle anymore. So this is used internally within the move generator to generate legal castling moves depending on the castling rights, to update the castling rights appropriately. Then we have piece offsets, which I use to generate the proper moves. So literally all these numbers are the directions of where the knight going. So let's take well, we don't even have pawns here, so well, let's take king. So say king is here, so here we'll have -16, here we have like -1, +1, and here we'll have like +16. Well, depending on the NDNS it might be different, but that's just the idea. So 16 is just kind of like 1 square ahead, 32 would be 2 square ahead, and the same for when it comes to the different direction. So how that's clear as well, we just try to play around with this if interested. But again, like, it's not intended to be changed, obviously, because that's the core that is already working nicely. Here on the right part of a chessboard, even though it's not used, but I was using these values for positional evaluation when I was experimenting with writing chess, a search algorithm, an alphabet search, based on this move generator. I didn't drop this, so you're free to use these values. It doesn't really give a strong positional play. Obviously, it's quite pretty poor, especially bearing in mind that the only positional square table is used for all the pieces. But still, I'm just keeping it because you could reset this all to 0, so it doesn't matter. It's not used in the library in this moment in particular. So, well, most likely, if you want somewhat a strong evaluation, you would probably want to create a custom piece square tables for every piece type, and even 2 sets, 1 set for opening, another for endgame, and interpolate the values depending on the material to make the evaluation more or less reasonable. But that's a completely different story. If you're interested about this topic, you can check out my Bitboard Chess Engine in C series. When it comes to evaluation, I was covering these topics in greater details. Here we have board state variables, so side to move in peasant square, castling rights, 50 move counter, hash key, 32-bit one, as was mentioned before. King square is needed is incrementally updated as well to make it faster, checking the fact whether the king has been exposed into a check or not, in order to make sure that when we're making a move on a chessboard, we need to make sure that king is not left within a check after the move is made. So this king square is some sort of an optimization of the move generator. The move stack, I was already talking about this. So this is the data structure that keeps track of whatever moves were taken from the GUI, either from if you're clicking the board with your mouse, or specifying the moves as several moves in a string. Like, I mean, here, if you specify moves here, as soon as you click the set button, this move stack is a data structure that gets populated, so moves would get populated. And how exactly comes a little bit later on. So again, like, pseudo-random number generator is needed to is used in order to generate a hash key or a unique position identifier eventually. So it's not intended to be used while it's possible, obviously. Zobrist keys. So this part is actually, so first we need to initialize this random keys. So this is just arrays of random numbers, basically piece keys, castle keys, just arrays of number of random numbers. Side key is a single random number, and then so this function just initializes this arrays. Then we're going to generate a hash key, which actually generates the unique position identifier, as I was already mentioning via. I'm not sure what got wrong with an indentation here. It's a bit strange to me. It's a little bit strange what has gone wrong with an indentation. Sorry guys, so just not exactly. Something has gone horribly wrong with an indentation. Yeah, now it's much better. So yeah, well, I hope I didn't break anything. It's still kind of working. Let me quickly check that out. Yeah, it seems like. So yeah, yeah, for some reason just there was the mix of tabs and spaces, and that's the reason why I wasn't really working that nicely here. But anyway, doesn't matter that much. So just I hope no errors. Okay. So board methods. Well, print board is quite pretty self-explanatory. It allows to print this sort of a board with side move, castling, rights and peasant square, 50 rule move counter, and unique position identifier, also known as a hash key. So this is what this print board function does. Again, like if you want this, say you want this print board function to be present within the API reference, you can just here down below you can say like just give you an example. So print board to console. So you can simply say like print board, and you just want to return the function. If the function takes some sort of an argument, you specify them here, and then when you call the function, but this board doesn't take any arguments, so it's literally enough to say just print board, and that's kind of it. So what you can do from now on you can simply say here like board dot print board, and if I run the code again, so here we had this move array, what was move stack was printed at the very last, and now it also prints the chessboard, but now it's not done from the tasks method, it's done directly from the API. So we've just added a new method to the API. So that's this should serve you as an example of an idea how one can easily extend this public API reference by adding kind of new sort of a function. So I hope that's clear as well. Let's get back to our print board and go further on. So the next print move actually not printing anything. What it does, it takes the move. Moves are encoded in as integers when they're made on a chessboard. That's again like another interesting topic to consider. You can check my either hexadecimal board, either hexadecimal move generator or bitboard chess engine in C series. They both use the same. Just want the indentations are a bit wrong here as well. They both use this sort of a. They both use. Okay, something is going horribly wrong with it, with this indentations for some reason. They both use moving code into the integers. So things like source square, target square, various flags like pawn start flag, capture flag, in peasant flag, castling flag. They all are being encoded within a single integer using a bit shift operations. And if we want to decode the move back, so to try and kind of like extract the source square, the target square, and in this case it's literally enough. Well, actually, it's literally enough to extract only source square, target square, and move piece if available. So if the promoted piece is available, we also want to extract that as well here. And this function converts the move, the integer encoded into an integer. It converts the move to the string, so you can have a string representation of the move like e2, e4. So in encoded version, it would be like 100 for from square, like 100 plus 32. Well, sorry, 100 minus 32. It would be the e4 square, and so on. But if you want to see it like e2, e4, you just pass the encoded move integer to this print move function, and you'll get the string back. So that's quite a pretty useful function. Print move list does literally what it claims. It just references the move list object that is passed as a pointer to this sort of a print move list function, and it just prints all the moves. This is done here, so this is the output of the print move list function, so I hope that's quite pretty clear. It also prints the total number of moves available overall. Reset board resets the board array and the board state variables. So here we'll loop over ranks, files, reset every board square to E, which means 0 or empty square. Then we're resetting the board variable side equals to -1, which means none of neither white nor black. So in peasant, no square is just the off-board square of the constant of 120, just the off-board value. Castling rights being resetted here. 50 rule move hash key king square has been resetted as well, and also we reset the move stack, because every time we reset the board, we need to make sure the move stack is getting resetted as well. Push move is the function that populates the move stack data structure within umove. Undo move just alters the current board position, so it goes to it decrements the move stack counter, sets the board position to the corresponding move that is available to the corresponding position that is available on the move stack itself. Redo does the same, but in the opposite order, so not decrementing but incrementing the move counter. First move does the same that undo, but it uses the fixed constant of move stack count equal to 0. And last move does the same, but the move stack count is equal to stack size -1. So literally pointing to the very last move in the move stack. And every time we call these functions, we update the board, so it's every time we can didn't yet move anything. So say we have populated the move stack. So when we taken moves back and forth, we just update the board state as well. So I hope that's quite pretty clear. It's blinking because my console is open and everything is getting reloaded instead of using the pre-cached version. So we just close this. It won't be blinking anymore. It would have been working in a normal way. Okay, let's move further on to move generator. Well, move encoding, something that I was mentioning already. So here is the scheme on how the move. Here is the mappings of how the move is encoded. So the first 7 bits is used to encode the source square. The second 7 bits are used to encode the target square. Then we are encoded the promoted piece if it's available, and then the flags capture, double pawn push, in peasant and castling. So one by one getting encoded here. Here is some helper functions to either encode move, which means to take source target and all the flags as an arguments and create and generate a single 32-bit integer representing the move, and all of these functions kind of decode the move back, so we can extract whatever of the flags or source square, target square, or promoted piece. So I hope that's quite pretty self-explanatory as well. Is square attacked is used in order to make sure that whether the king has been exposed into a check or not. So it's quite pretty similar to what move generator does, but in a little bit reversed order. So if we just find a piece with a given offset for every pawn for every piece respectively, then we return true, which means that it is attacked. Otherwise we return 0, which means false, that it's not attacked. So for pawns, for slider pieces, for for kings, for knights, for bishop and queens, rook and queens. Yeah, that's it. Print attack map is a function that calls a square attack for every single square, depending on what site you are interested to get attack map for. Well, this is worth of showing probably. So let me show you how print attack squares works. So we just go to tasks here. So I just can say print attacked squares, and let's say for white, and if you just update this, open the developer tools. Yeah, just a little typo, sorry. And it should print the attack map. Yeah, and here is the attack map. So axes represent the squares that are under attack by the given site. So these are the squares that are attacked by the white piece. So you see, like, these two pieces are attacked by this sort of a knight. So one here, one here. So these are the attacks and so on. So I hope that's also kind of clear. Let's get back to what we were looking for. So print attack squares, okay. Generate moves is one of the core functions, which literally populates the move list structure with all the pseudo-legal moves available in a current given position. It's too tricky to explain it. Again, just better watch my hexadecimal 88 move generator tutorial here on Chess Programming channel that live codes this sort of a function with deep explanations on how the things works. But from the user's perspective, it just after this function ends, we have a move list that I've been showing you before being updated, being filled with the moves, with a pseudo-legal moves. By saying pseudo-legal, I mean this move generator doesn't check whether the king has been exposed into a check or not. That would be the matter of the make move function, which we're coming to now. Now you might be a little bit confused by this flag, all moves and only captures. Well, in this particular implementation, it doesn't work. It's not getting involved at all. It's just yeah, I was using this when I was experimenting with the search. Basically. So the search is the function that takes the board position as an input and gives the best move as an output, which is literally the job of a chess engine. And in a search, there is a function called quiescent search, which does exactly the same that the search does, but by only generating captures, not all the legal moves, but only generating captures. And this capture flag allows make move to make only captures if needed. So in this library, it's not really needed that much, but I just kept that. So if you would ever want to build a search driver kind of chess engine on top of this move generator, you could have make use of this capture flag. So your make move function would be making only captures and not all the moves. And if you specify like all moves as the second parameter, it would be making all the moves. So in here, in this particular implementation, we use all moves all the time. So just to give you an idea what this capture flag and all moves and only captures are all about. So again, so if we have quiet move, we come here in this block. If we have a capture flag, we come here, and here we're just checking out if the move is the capture. Then we make it by swapping this flag. If not, we just return 0. It's meant even though the move might be legal, we return 0, not making it on board because it's a it's a quiet move. Okay. So make move, again, it's quite a pretty complicated function that serves the purpose of altering the board state depending on what kind of move we have. So apart from just simply moving the piece on the board, we need to make sure that in peasant square is updated, castle and right is updated, side move has been shifted, that we have the incremental updates for hash keys. So that's another kind of tricky thing. And again, like all this stuff is available in my tutorials on chess programming channel, so feel free to check out my how to code a chess engine playlist, like either Bitboard Chess Engine or Hexadecimal 88 move generator. Everything is covered there. Perf Test is here we have two functions that literally running the move generator recursively to count the nodes being visited, and that's the measure of accuracy of your move generator. So if you have the number of I've been showing you this in the very beginning of the video. So if you have traversed the specific number of nodes, that means that your move generator is generating legal moves. If that number doesn't match the one you were comparing it with, that means that your move generator, say, generating some wrong moves, either leaving king being exposed into a check, or not handling in peasant captures, or not removing the pawn during in peasant capture. Tons of bug possible there. So perf testing is something that allows you to make sure that your move generator is actually bug free, and this kind of library passes the perf test, so I hope that's quite pretty clear. So input and output. setFEN takes the FEN string as an input and sets the board position and state variables appropriately, so nothing much. So quite pretty trivial here. Also generates the hash key for a current given position and updates the board. So this update board allows to actually redraw, re-render the pieces on a chessboard to have a proper position here. Is move valid is an interesting function that takes a move string as an input, then it just creates the move list, generates moves, and it finds this move string within the moves, assuming the promoted pieces as well. Then it returns true, otherwise then it returns the encoded move that you can make on a chessboard, otherwise it returns 0, which means that the move is illegal. Read moves is the function that processes whatever moves were input here and validates them, and if the move is valid, it pushes the moves onto the move stack. So quite pretty self-explanatory. Now we come into the very last part, is the GUI. So here we have the board appearance variable, so light, dark, square, and select color. So these are the default values. So what you see here on your screen are considered to be the default values. Okay, so I've already been showing you how one can change them. So again, like, so you just need to specify a bit of parameters. So let's have a look. You just need to specify like board size. Well, just to give you an idea of how it works. So you can make, say, a bit smaller board as well, apart from well, obviously it does affect the entire GUI, so you need to take care of that as well, but it just changes the colors of light squares, dark squares, etc. So you can make a really tiny chessboard, to be honest. So it's even like this, and still it would be working like so. That's kind of how it works. You can create multiple chessboards, which is also a nice option, by the way, but I prefer this. So 400 is a standard. If you don't specify that, that's the standard size for a chessboard. If you don't specify those, so again, like you can, I just don't want to crush these values. So you can say here you're like red, and it just gets red. So I hope that's clear. Okay, okay. Hope I didn't. Did I just stop the recording? I'm sorry. Just pressing Control R, which means to refresh the screen in the browser, but also it's the keybind to stop my recording software. Okay, so well, anyway, let's get rid of this to get to our initial board colors. Okay, so just dropping back to the GUI, and again, like if we have if the board function, this eventual constructor that we're using here, object constructor, if this one, if it has this is called width, light square, dark square, and select color. If they have been specified, it's been referenced one by one. So width is specified, just alters this. If whatever of color has been specified, it alters. If it wasn't specified, it would be using the default value from here. It's quite pretty self-explanatory. Click lock variable is something that is needed to distinguish between clicking on the source square and on the target square to properly extract the user source square and target square, to construct a move, to pass this move to pass this move string to the isValid function to validate the move, and if the move is valid, we return back an integer representation of the move, which not only moves the pawn on the board but also updates the board state variables, like say here we're getting in peasant square being set to e3, and so on. Changing the board, changing the side. If this was a rook move or a king move, it would alter the it would respectively alter oh my god, the castling rights. So we can't just move these pictures on this visual representation of the board. We need to alter the internal board state properly to make sure that the position would be legal and we make all the legal moves. Okay, so user source and user target are the variables that are actually holding the source and target square entered by the user, regardless whether we are using drag and drop or 2 clicks. So every time this square is being updated, and you always can keep track of all of these variables within the move piece function, which we'll cover a bit later on. So whatever function, you can just add this console log lines to keep track of what's going on with the internal variables. So drawboard creates a table, HTML table. I know this is quite pretty rare, but I really like table for board representation, because that is something that was used in Nano Chess by Oscar Toledo. So this is some sort of a tribute to that minimalist implementation. We have a simple border for a table, 1 pixel, solid black, so you can override this obviously if you like. And then for every TD stands for, so TR is a table row, so this literally like row 1, 2, so this handles kind of the ranks. And here we're handling the kind of like files, so table data, TD stands for table data tag, so align center. Background color, depending on is this even or odd square, we're making the background either equal to the dark square or to the light square. The width is being calculated using this cell width and cell height. On click, we're calling this an important thing. You remember I was asking you guys to name the board instance exactly board and not something else, and that's because this on click, on drag start and drag over and on drop uses the board object instance that is called board. So if you just want to alter it there on creation, so if here you want to say like board 1, then here you need to say board 1 like this. Otherwise it won't be working. So I hope that's quite pretty self-explanatory as well. So let me check quickly if I didn't really break anything. Yeah, so okay. Okay, and now what else? Closing the TR tag every time we hit in another row and this table. So literally this creates a valid HTML that will later on assign to the inner HTML of the chessboard div. So we're getting the chessboard div by ID and setting the internal the inner HTML attribute to this chessboard, which is a string representing the chessboard as the set of as the table tag, including table rows and table data tags inside. So this sort of a chessboard div identified by this ID is being filled with a table, rows and columns, things like that. Okay, let's move further on. So update board is the function that literally draws the pieces on board. So it loops over internal board ranks and false. As always, make sure that the square is on board, and then the inner HTML of whatever square. So we're getting element by ID. So here we're setting the ID to match to fit the internal board square encoding. So let's say if square A1 is equal to 0, this means that the ID of this table data tag would be 0, sorry, as well. So we just inspect the element so that the ID would be equal to 0, just like, oh, it's actually, hold on a second, no, it's the image. ID is equal to 0, 10 is the ID of the picture. It's a bit different story. Probably it's not even used, I don't even remember now, but anyway, the TD, which stands for table data, so this is the square, it has the ID of 0. And this one would be the ID of 119, because this is what H, this is it, because this is what, this is the code of the square H8. So we loop over the board, squares, finding the square, and if there is a piece there, in that case, we actually, hold on a sec. Oh yeah, I'm also adjusting the width of the image, so we need to make sure that images are getting resized every time when the board cells are resized. So that's the line that is responsible for that sort of stuff. And also we're referencing the board square, whatever is there on the internal board, and we're getting back a piece code, and then we're using this piece code as the file name of the corresponding GIF image that we have here. So let's say we have, so wipe 1 is encoded as 1. You remember it from the previous stuff. So if we, at the board indexed by the square, we're having a wipe pawn. Then it means that we want to draw the wipe pawn in the GUI, and to formulate, formulate a file name for this pawn, we're using the piece code of wipe pawn and use it as a file name. So the same for all the other pieces. We have this 0 for 0 we have nothing. This is the transparent GIF, so nothing is available there really. So that's how we render our pieces, and every time the board state is getting updated, so the pieces changing their own places after, say, parsing FEN, putting moves onto the move stack while firing read move function, or just moving the piece from one square to another using the move piece function, the internal board state gets updated, and we need to redraw the pieces, and that's where the update board function is used. If you want to use this update board function from the API, you can just add the reference to this update board function, and you would be able to call it like I was calling tests here. So say like board.update board if needed. Again, like so, it's all on the developer basically. Okay, so here we have this drag piece, drag over, drop piece. So these functions are handling the drag and drop events when they occur in the GUI. Tap piece handles 2-click piece movement, and regardless of whether we drop in the piece, we need to call the move piece to actually change to alter the location of the piece. Also, some highlights is handled here, and we also call move piece when we using the tap piece, which means like two clicks to move the piece. Anyway, regardless of whether we use the 2 square clicks or drag and drop, eventually we're calling the move piece, which which actually validates the move, and if the move is valid, it makes the move on the internal chessboard, and then it updates the board to render the pieces, the updated pieces on the chessboard. So here I have promoted piece being hard coded to white queen. Well, actually it could be black queen as well, I guess, because it doesn't really matter that much. Or hold on a sec, yeah, probably it won't even be promoting to black queens. I'm not sure. Need to check that out. Well, doesn't matter. So in the real implementation, the promoted piece should be taken from the GUI input as well. So whatever piece a user considers to promote his pawn to should be assigned to this promoted piece variable. So that's quite pretty important thing here to consider. Then we're generating the move string by converting the user source and user target, which are the board indices. Basically, we're converting them to human readable coordinates like E2, E4. And again, like this promoted piece is hard coded from this Quint, but this is still working, believe it or not. Then we create the valid move, which in case if the move is valid, gets assigned, it gets the value of the encoded move, which we can pass to make move later on to actually make the move in a chessboard. So if the move is valid move is not equal to 0, which means that we did return an encoded move, in that case, well, this is the condition to either push or not push the move to the stack, depending on the count. But anyway, we want to make the move on a chessboard, and then we want to push this move onto the move stack. So that's how it works. And well, here I'm just updating the last square. This is not even needed, I guess. Last square. Let me just. Yeah, this is not needed. So let me just make sure that I didn't break anything still. Okay. Okay. Yeah, it doesn't affect. So I was experimenting with a highlight, and yeah, that variable is not involved anymore. And at the very end, we're updating the board as well to fix some highlighting bugs, let's say, and also some highlighting as well. And finally, we update the board, and every time the move is made on the board, regardless of the current click lock state, so whether we click on the source square or on the target square, we reset the click lock to make sure that the move is made on the board. So if we want to reference the from square, so whatever square would be clicked next, if it's possible, it would be considered to be the from square. So that's it. The only initializing stuff here that runs automatically on the time of the object creation, we just initializing the random keys and initializing the initial hash key for a starting board position. So this stuff is not intended to be taken, but if you want to initialize some additional stuff within this library, you can add your initializing logic here, regardless whether this is a variable initializations or calling a function that would be initializing some variables on its turn later on. So tests has been covered already. So here just we can easily interact with internal variables and methods. And this is the API. So whatever, again, like whatever variable, internal variable or internal function you want to give a public reference to, you can do it here by specifying the name, how to call it. So whatever you have here, it would be like board dot read moves, and this code would fire. Let's say board dot print board, this would fire. You can it's not obvious to have the same name here and here. Here you can have one name, here you can have another name. So it's all on you basically. And yeah, this is basically it, guys. So as you can see here, kind of a lot of job has been done. But again, like as I've been mentioned already in the very beginning of this video, I can't really see the particular application of this sort of stuff. So that's the reason why I say that this is more like intended for tinkering rather than for some sort of a production. So if you want to learn about chess programming in terms of how the move generation, move validation works, and how the basic GUI works, how the interaction with these two works, this JavaScript library is very simple. Every single line of code has been committed, so you can go and tinkering with this, trying to learn how the things work. If you want to write a chess engine based on the move generator presented here, that is also possible. Just take the move generation code. You can use it either as purely global variables in a separate file if you want, or you can make, or you can provide a search algorithm here within the library itself. So you're absolutely free to do whatever you want with the source code, and that's literally it. If you will build something interesting using this sort of a JavaScript chessboard library, please let me know. As the author of this stuff, I would be incredibly interested in having a look of what you guys in particular manage to do with this sort of a library. This is it from my side. CodeMonkey King was with you guys. Hope to see you in the next tutorials here in CodeMonkey King, here on Chess Programming channel. Until that time, and take care.